The product rule for derivative in prime and limits notation is presented. The first formula presents product rule for derivative in prime notation. The second formula in Leibniz notation. The first example, we have to find derivative in prime notation for the following function. We will use product rule in prime notation. uv prime equals u prime v plus uv prime. The first factor, e to the x, it would be u. The second factor, sine x, it is v. Now, according to our formula, we can write derivative of our given function. It would be e to the x prime times sine x plus e to the x times sine x derivative. Now, e to the x derivative, it is e to the x times sine x plus e to the x. Derivative of sine x equals cosine x times cosine x. We have common factor e to the x, e to the x. We can simplify a little bit our answer. It would be e to the x, open parenthesis, sine x plus cosine x. It is derivative of our given function. The second example, we have to find derivative in Leibniz notation. According to our formula, df over dx equals the first factor 2x cubed minus x plus 1 d ln x over dx. It is our derivative of ln x in Leibniz notation, plus the second factor ln x and derivative of the first factor d over dx of 2x cubed minus x plus 1 equals. We keep the first factor 2x cubed minus x plus 1. A derivative of ln x equals 1 over x. We can write times 1 over x plus ln x derivative of 2x cubed minus x plus 1 equals 6x squared minus 1. We remember derivative of number equals 0, so derivative of 1 equals 0. We can simplify a little bit. It would be 2x cubed minus x plus 1 over x plus 6x squared minus 1 times ln x. It is derivative of our given function. Example 3. We are going to find derivative in prime notation. We will use prime notation derivative. uv prime equals u prime times v plus uv prime. We have to find derivative function e to the t times 4 minus 1 over t prime. The first factor of our function e to the t, it would be u. The second, 4 minus 1 over t, it is v. Now follow to our formula, we can write e to the t prime times the second factor plus e to the t times derivative of the second factor. Okay. Derivative e to the t equals derivative. Derivative equals function in this situation, so it would be e power of t times 4 minus 1 over t plus, we keep the first factor, and derivative 4, right here, derivative 4 minus 1 over t derivative equals 4 derivative minus 1 over t derivative. Derivative of number always equals 0. Does everyone remember? So it is 0. A derivative negative 1 over t, we can write like negative t negative 1 prime equals, now we can use power rule. So it would be minus negative 1 times c negative 1 minus 1 equals minus minus give us plus, and finally it would be c negative 2. So derivative of the second factor equals c to the negative 2. Now we can simplify a little bit. We can see we have common factor here, e to the t, and we can write answer. It would be e to the t, open parenthesis, 4 minus 1 over t plus, do you remember t to the negative 2? We can write using negative exponent property like that, 1 over t squared. We find derivative of our function h of t. Next example. We have to find derivative in Leibniz notation. Leibniz notation. It is prime notation, so it doesn't work for us. Leibniz notation for h of t function, it would be d of h over dt. After we follow our formula, we keep the first factor ln t times derivative of the second factor. So it would be d cosine t over dt plus cosine t d ln t over dt equals, we keep ln t factor and we have to multiply by derivative. This is derivative of cosine t. Derivative of cosine t, it would be negative sine t plus cosine t times, this is derivative of ln t. Derivative of ln t, it would be 1 over t. Now we can write our answer, negative ln t times sine t plus cosine t over t. So it is our derivative, negative ln t times sine t plus cosine t over t. It is derivative of function h of t equals ln t times cosine t. Example number 5. We have to find derivative in prime notation. For prime notation, we have formula u v prime equals u prime v plus u v prime. Now we have to take u, it would be the first factor of our function, it is u. As the second tangent x, it would be v. So now we can write, so the first factor, derivative of the first factor, square root of x cubed minus 5 over x squared derivative times the second factor, tangent x, plus the first factor, it would be square root of x cubed minus 5 over x squared times tangent x derivative equals. Now we can find derivative. Square root, I will write here, square root x cube derivative equals x 3 over 2 derivative. It would be 3 over 2, we have to use power rule. 3 over 2x, 3 over 2 minus 1. Give us 3 over 2x 1/2. So now we back. It would be, open parenthesis, 3 over 2x 1/2 minus. What is derivative 5 over x squared? 5 over x squared derivative, we will use power rule as well. We can simplify a little bit. It would be 5x negative 2 prime. Power rule, we remember we have to take negative 2 right in front. It would be negative 10x negative 2 minus 1. So give for us negative 10x negative 3. Okay, so it is derivative 5 over x squared minus 2 minus 10, and we have minus inside, so give us plus 10 x to the cube negative times tangent x plus the first factor square root of x cube minus 5 over x squared, and tangent x derivative equals secant square x. We found derivative of our given function. Thank you for watching and see you soon.